Hello, everyone, and welcome to this presentation on applying human performance technology to online learning environments. My name is Anna, and I'm from the School of Education at Liberty University. In this session, we'll explore how a powerful framework, human performance technology, or HPT, can be used to significantly improve our online learning experiences. This topic is incredibly relevant today as digital education continues to expand and evolve. Understanding how to systematically address challenges and optimize outcomes in this space is crucial. I have no known conflict of interest to disclose, and you can reach me at the email provided on the slide if you have any questions. Let's dive into the core of our discussion. This presentation will explore how the human performance technology model offers a robust framework for optimizing online learning environments. Think of HPT as a systematic toolkit designed to enhance performance, whether it's individual or organizational. We'll meticulously examine how each phase of HPT, from the initial analysis right through the evaluation, can be applied to pinpoint specific gaps and significantly improve outcomes in digital education settings. The ultimate goal here is straightforward yet impactful: to improve effectiveness, efficiency, and overall human performance within the rapidly advancing landscape of online education. It's essential we are looking for ways to make online learning not just functional but truly impactful and streamlined. Human performance technology. At its heart, HPT is a systematic approach designed to improve both individual and organizational performance. It's not just about training, it's about identifying performance gaps, deeply analyzing the root causes, and then crafting the most appropriate solutions. As Saporsky and colleagues pointed out in 2024, HPT practitioners identify deficits, devise solutions, implement them, and then crucially evaluate their effectiveness. A key characteristic of the HPT model is its focus on finding the right solution based on the root cause rather than immediately defaulting to instructional interventions. This solution agnostic approach is what makes HTP so powerful. HPT model is typically broken down into five core phases. First, we have performance analysis. This is where we pinpoint exactly what the desired performance is versus the actual performance, identifying any gaps or opportunities. Once a gap is identified, the next phase is cause analysis. Here we dig deep to determine the underlying root causes. Are they environmental, instructional, motivational, or even systematic? With a clear understanding of the root causes, we move to the intervention, selection, design, and development phase. This phase involves choosing, designing, and developing tailored interventions. HPT's interdisciplinary nature allows for a wide range of both instructional and non instructional solutions. Following this, the implementation and maintenance phase is about putting these selected interventions into practice and ensuring their continued effectiveness. And finally, the crucial phase of evaluation. This is where we assess whether interventions actually closed the performance gap and achieved the desired outcomes, ensuring sustainable improvement, as Saporsky and colleagues described in 2024. Now let's bridge the HPT model with the world of educational technology. The application of HPT model is particularly powerful within the online learning environments, precisely because we can leverage various types of educational technologies. The digital landscape has evolved so rapidly that technology mediated learning has become dominant for both educational and professional development. Our focus here is on the range of tools and systematically specified designs to improve learning and performance in these digital settings. Some key educational technologies relevant to online learning. First, we have mobile performance support systems, or MPSS. These systems deliver just in time, just enough information directly via mobile devices, focusing squarely on performance outcomes. They're incredibly applicable for improving task quality in online work settings, as highlighted by Hahn and Klein in 2023. Next, AI-enabled chatbots are making significant waves. They can provide quick, relevant responses, addressing performance gaps like poor advisor to student ratios, as Lucian pointed out in 2021. They even can be explored for innovative applications such as teaching complex human traits like empathy in online learning environments, a fascinating prospect mentioned by Roy in 2021. Gamification, often a design element integrated with other tools, is considered a performance intervention. It's used to significantly enhance learner motivation and engagement, something we'll see in studies like Colin Pascal in 2024. Intelligent tutoring systems, or ITS, can be profoundly influential to student motivation, satisfaction, and learning performance. They do this by systematically analyzing the causal factors like knowledge, system, and service quality, along with task technology fit as described by UC in 2019. Furthermore, digital repositories like learning management systems, or LMSs, like SharePoint or Vital, they enhance communication, provide crucial resources, and facilitate just-in-time self-paced learning. LMS-based training, according to Sumiko et al. In 2025, is a primary avenue for the acquisition of knowledge that is oriented towards performance results. Finally, digital badges serve as a model form of digital credentialing. They document both formal and informal learning in e-learning contexts and are being explored for their potential to validate acquired skills and address performance gaps in hiring and promotion, as noted by Pascal and colleagues. Collectively, these technology represent powerful tools. When applied systematically through an HPT lens, they can dramatically enhance the effectiveness and efficiency of online learning environments. We'll apply the HPT model directly to online learning, starting with performance analysis. In this context, performance analysis means pinpointing specific performance gaps within a course, a learning platform, or even an entire online learning ecosystem. This isn't just about the individual learners. It can involve identifying broader organizational performance deficiencies that manifest in online settings, as Kaporsky and colleagues highlight in 2024. For example, performance analysis might involve assessing an instructional challenge in online teaching. Think about issues like inadequate tools, limited skills among instructors, or even their misconceptions about effective online pedagogy. Richardson et al. In 2023 conducted a campus-wide needs analysis that revealed these very issues, setting the stage for intervention. Similarly, performance analysis could identify gaps stemming from poor advisor to student ratios and departmental financial constraints in online academic advising, a problem Lucene addressed in 2021. These aren't necessarily instructional problems, but performance issues within the system. In a more nuanced example, Roy in 2021 even applied performance analysis to identifying declining empathy as a critical performance gap within the online learning challenge. This shows how broad the scope of HTP can be. Essentially, this initial phase is crucial because it sets the stage. It's about clearly understanding what needs to be improved within our digital learning ecosystem before we can jump into conclusions and solutions. Once we've identified the performance gaps, the next crucial step in HTP is cause analysis. This phase is all about determining the root causes of those gaps within online learning environments. It strongly aligns with HTP's principle of solution agnosticism, meaning we don't jump into a solution until we understand the underlying problem. We're asking, are the issues due to environmental factors such as poorly designed online platforms or a lack of accessible resources? Are they due to instructional shortcomings like an ineffective curriculum or poor teaching methods? Could they be motivational problems, perhaps a lack of student engagement or perceived irrelevance of the learning contents? Or are they deeper, more systematic issues like restrictive policies or an organizational culture that doesn't support online learning effectively? Consider the example of declining empathy we mentioned earlier. A cause analysis in that scenario would question whether technology itself, including AI, might actually contribute to this deficit by mitigating genuine human connection, as Roy explored in 2021. Or when looking at the intelligent tutoring systems, cost analysis involves systematically breaking down factors like knowledge quality, system quality, service quality, and how well the task fits the technology, all of which influence student outcomes, as Use et al. Found in 2024. Understanding the root causes is absolutely crucial. It's the foundation for which we can select the most appropriate and effective technological interventions. We thoroughly analyze the root cause of performance gaps. We move into the intervention selection, design, and development phase. This is where we get creative, choosing and crafting tailored interventions using various educational technologies, always based on those identified root causes. HTP's interdisciplinary nature is a huge advantage here. It allows for a wide array of technological solutions, not just a one size fits all training. For instance, this phase might involve the creation of tailored online learning modules or interactive simulations that address specific gaps. We could implement mobile performance support systems or MPSS designed to deliver just in time, just enough information right where a learner needs it, effectively addressing performance gaps in online work settings as highlighted by Huang and Klein in 2021. Consider the case where communication was a root cause of dissatisfaction. A SharePoint site, an educational technology tool, was implemented to enhance communication and provide resources, directly impacting teacher satisfaction and performance, as seen in RD's 2024 study. Similarly, a digital repository like Portal was developed using a designed research based approach and the HPT framework. This addressed instruction challenges by providing just in time, self paced resources for online teaching skills, a solution pioneered by Richard et al. In 2023. To tackle academic advising performance gaps, an AI based chatbot was developed as an HPT intervention to generate quick, relevant responses as documented by Lucin in 2021. And in a more forward thinking application, Roy explored using AI to teach empathy, stressing the critical importance of human centered design to ensure genuine connection in such interventions. Digital badges also function as powerful interventions. They validate acquired skills and address performance gaps, often enhancing learner motivation through gamification, as shown by Cal Pascatel et al. In 2023. These badges document both formal and informal learning in e-learning contexts. Furthermore, LMS-based training is highlighted by Sotomika et al. In 2020 as a primary avenue for the acquisition of knowledge that is oriented towards performance results. And Zhang's 2009 concept of soft performance technology, or SPT, even suggests designing HPT interventions within online learning systems that foster adaptable and self directed improvement for knowledge workers whose workplaces are increasingly online. These examples demonstrate the vast potential for leveraging educational technologies to design targeted, effective HPT interventions. Once interventions are designed, we move to the implementation phase. This is where we actively deploy the chosen educational technologies into the online learning environment. A critical aspect here is ensuring that the technology integrates seamlessly with both existing systems and crucially with current user practices. It's not about flipping a switch, it's about a thoughtful integration. For example, successfully implementing AI, as Roy points out in 2023, requires a thorough understanding of its real impact of human learning. We need to consider how it changes interactions, motivations, and the overall learning process. The development of Portal, the digital repository we mentioned earlier, is a great illustration of a robust implementation. It involved an iterative design based research, or DBR, process, which was optimized through the HPT framework. This has meant that during its deployment, there was continuous, ongoing evaluation and modification. This iterative approach ensures that the technology isn't just introduced, it's refined and maintained to genuinely meet the needs of the users and the learning environment. It's about more than just a rollout. It's about ensuring sustained usability and effectiveness. Finally, we arrive at the evaluation phase, which is a truly critical and continuous aspect of applying HTP to online learning. This is where we rigorously assess the implemented educational technologies have effectively closed the performance gaps and achieved their desired outcomes. This phase often involves rigorous data driven measurement. For example, Sudamika and colleagues in 2023 demonstrate the integration of the widely recognized Kirkpatrick model for evaluation within an LMS based training. showing a structured approach to assessing learning impact. When AI is used as an intervention, as Roy explores in 2024, evaluation faces the complex task of accuracy, measuring abstract comments like empathy's development in tech rich environments. This requires creative and robust assessment strategies. The effectiveness of an AI based chatbot designed to improve academic advising was meticulously assessed during its evaluation of the intervention phase, as detailed by Lucen in 2023. Similarly, USAY and colleagues in 2024 investigated how intelligent tutoring systems, ITS, influence student motivation, satisfaction, and learning performance, directly reflecting HPT's focus on evaluating interventions to achieve specific performance goals. Digital badges, Callow and Pescatel et al. 2021 assess their value and worth in the job market, echoing HPT's emphasis on measurable results and real world impact. The iterative design based research process for Portal, the digital repository involved in continuous evaluation and modifications, this ongoing feedback loop ultimately led to the development of an HTP model for designing digital repositories, as Richardson and colleagues explained in 2023. This continuous evaluation is important because it ensures sustainable improvements in online learning outcomes, reinforcing the cylindrical nature of the HPT model, as Saporsky and his co-authors remind us in 2024. In conclusion, the human performance technology model significantly enhances online learning. It provides an incredibly robust framework that guides professionals through a comprehensive, systematic process. This includes meticulously analyzing performance issues, deeply analyzing the causes of those performance gaps, and then designing targeted interventions, implementing those solutions, and finally, rigorously evaluating their effectiveness. This structured approach offers a clear roadmap for identifying and effectively closing performance gaps within digital education. It directly links to achieving performance oriented knowledge in online trainings, driven by a cycle of continuous improvement through ongoing evaluation. HPT truly stands out as a practical and adaptable tool for online learning environments. We've seen how various educational technologies serve as powerful HPT interventions. Mobile performance support systems effectively reduce cognitive load for learners. SharePoint not only provides a platform for collaboration, but also dramatically improves communication within educational settings. AI-enabled chatbots have been shown to significantly improve critical functions like academic advising. The broad scope of HTP allows it to address a wide spectrum of challenges in online learning, from its purely technological standpoint, like leveraging technology for the knowledge of workers who operate predominantly online, to deeply human-centric, such as fostering empathy in digital learning environments. Ultimately, HPT empowers educators. It gives them the tools to accurately diagnose challenges, implement precisely targeted solutions, and officially measure the impact of those solutions, leading to consistent and measurable improvements in online education outcomes. I hope this presentation has provided a clear understanding of how the human performance technology model can be effectively applied to enhance online learning environments. Please leave any questions you may have in the comments below. Other references that inform this presentation. These scholarly works highlight the robust research and practical applications of human performance technology and educational technology in various contexts. They provide the foundational knowledge for underscoring how HPT can effectively be leveraged to optimize online learning environments. Thank you so much for your time.